Have you ever stopped to consider what the future of energy storage might look like, and the role that quantum physics could play in it? As we journey into the 21st century, we're faced with the limitations of our current energy storage methods. You see, in a typical battery, charged ions navigate through a sea of particles, moving one way as the battery recharges, then racing back in the opposite direction to release stored energy. This back and forth dance continues until the battery's capacity is drained, causing it to lose energy too quickly to be of much use. But what if there was a different way? Enter the world of quantum physics. Here, scientists are envisioning novel methods of storing energy in portable devices, leveraging a peculiar quantum phenomenon that, among other things, twists time. Unlike traditional batteries that use chemicals like lithium to store charge, quantum batteries employ microscopic particles like arrays of atoms. Take Yuanbo Chen, a physics graduate student at the University of Tokyo, and Gaoyan Zhu, a physicist at the Beijing Computational Science Research Center. They're spearheading the development of a quantum battery that allows for simultaneous charging stages, potentially enhancing energy storage and thermal efficiency. Chemical batteries obey the classical laws of physics, but microscopic particles are quantum in nature, giving us the opportunity to explore new methods that challenge our intuitive understanding of what happens at small scales, Chen explains. Chen, Zhu, and their team are not the first to envision how a quantum battery might work, but they've taken the crucial step of testing their ideas experimentally, using a lab setup filled with strategically placed lasers, lenses, and mirrors. Their approach draws on a quantum phenomenon known as superposition, which allows particles to exist in a multitude of possible states until they're measured. This overlay of possibilities also disrupts the natural order of time, as researchers have recently shown. So, what does this mean for the future of energy storage? Well, it could be a game changer. Quantum batteries, once purely theoretical, are now within the realm of possibility. The science fiction of yesterday is becoming the reality of today. As we press on into the future, the line between science fiction and reality blurs. Quantum batteries, once a theoretical concept, are now within the realm of possibility. To understand quantum batteries, we first need to demystify quantum physics. Imagine this. You're flipping a coin. It's either going to land on heads or tails, right? Well, in the quantum world, it's as if the coin is both heads and tails at the same time until you look at it. This is what physicists call superposition. It's the idea that a particle can be in multiple states at once, only settling into one when it's observed. Now let's take it a step further. Picture two dancers on opposite sides of a stage, moving in perfect harmony. No matter how far apart they are, they mirror each other's moves instantaneously. This is a somewhat simplified representation of quantum entanglement. It's a peculiar phenomenon where two or more particles become intertwined in such a way that the state of one instantly influences the state of the other, no matter the distance. But here's where things get even more interesting. In our everyday lives, we're used to events happening in a certain order. You flick a switch, and then the light comes on. But in the quantum realm, this linearity breaks down. Thanks to superposition, events can unfold along multiple paths at the same time, so, in a sense, the light can come on both before and after you flick the switch. This is the quantum superposition of causal orders, a mind-bending concept that challenges our conventional understanding of time and sequence. Now, you might be wondering, what does all this have to do with batteries? Well, these strange quantum phenomena are precisely what scientists are leveraging to revolutionize energy storage. By applying these quantum principles, they're exploring new ways to store and retrieve energy more efficiently than ever before. Quantum physics, while complex, gives us a fascinating glimpse into the fundamental workings of the universe. With a basic understanding of quantum physics, we can now look at how quantum batteries could work. Imagine a world where your smartphone battery doesn't drain away after a few hours of use. This is the world that Yuanbo Chen, a physics graduate student at the University of Tokyo, and Gaoyan Zhu, a physicist at the Beijing Computational Science Research Center, are working towards. They're exploring the idea of a quantum battery, a device that uses arrays of atoms to store charge instead of chemicals like lithium. In their latest work, Chen and Zhu have been investigating the concept of simultaneous charging stages. What does that mean exactly? Well, in a traditional battery, ions move back and forth, losing some energy each time until the battery's capacity is drained. A quantum battery, however, could allow for all the charging stages to occur at once, dramatically improving both energy storage and thermal efficiency. This might sound like the stuff of science fiction, but it's rooted in the very real and very strange world of quantum physics. As Chen explains, while chemical batteries are governed by classical laws of physics, microscopic particles are quantum in nature, so we have a chance to explore ways of using them that bend or even break our intuitive notions of what takes place at small scales. Indeed, Chen, Zhu, and their colleagues are not the first group to envision a quantum battery. Past research has suggested quantum batteries that never lose their charge, thanks to a mechanism that puts quantum components into a dark state where they can't lose energy to their environment. But Chen and Zhu's approach is different. It's based on the quantum phenomenon of superposition, where particles exist in many possible states at once until they're measured. This concept doesn't just bend our understanding of physics, it also messes with our perception of time. In the quantum realm, the linear order of cause and effect breaks down. Superposition allows for events to unfold along two paths at once. This means that an event following another can also influence the previous event as if it came before. To apply this to energy storage, Chen, Zhu, and their team used a quantum switch to create a system capable of pulling from two charges at once. The work by Chen, Zhu, and their colleagues shows the potential of quantum batteries to revolutionize energy storage. A key concept in quantum batteries is quantum superposition. But how does it relate to energy storage? Let's delve into the intricacies of this fascinating phenomenon. Quantum superposition is a fundamental principle of quantum mechanics that allows particles to exist in multiple states at once. It's like being in two places at the same time, or spinning both clockwise and counterclockwise simultaneously. This defies our understanding of reality as we know it, where things must exist in one state or the other, not both. In the realm of quantum mechanics, however, the rules are different. Here, particles can live in a state of superposition until they are measured or observed. At that point, they collapse into one state or another. But until then, they inhabit a world of possibilities. Now, how does this relate to energy storage? Imagine if we could harness this concept for batteries. In classical physics, energy storage and release occur in a linear fashion. A battery charges, then discharges. It's a one-way street, with energy flowing from point A to point B. But what if we could have energy at points A and B at the same time? That's where quantum superposition comes into play. The application of quantum superposition to energy storage involves the use of a quantum switch. This switch allows a system to pull from two charges simultaneously. Instead of energy storage being a one-way street, it becomes a multi-lane highway, with energy zipping back and forth along multiple paths simultaneously. This could lead to more efficient charging and energy use, as well as batteries that can hold their charge for longer periods. The idea of bending the rules of time and space to improve energy storage may sound like science fiction, but it's a very real possibility in the world of quantum mechanics. Quantum superposition could revolutionize the way we think about and use energy, leading to more efficient and powerful batteries. Through quantum superposition, energy storage could be transformed, leading to more efficient and powerful batteries. So the next time you charge your phone, consider the quantum possibilities. The theory of quantum batteries is fascinating, but what could be their real-world impact? As we delve into the potential applications of quantum batteries, we find that they could revolutionize numerous sectors, including electric vehicles and renewable energy. Imagine an electric vehicle powered by a quantum battery. It could potentially charge faster, run longer, and even be more sustainable than current models. The unique properties of quantum physics could allow for increased efficiency in energy storage and release, making electric vehicles more practical and accessible. This could be a significant step towards reducing our reliance on fossil fuels and decreasing carbon emissions. Moreover, quantum batteries could be a boon for the renewable energy sector. Solar and wind energy are intermittent sources of power, and one of the biggest challenges they face is how to store the energy they generate for use when the sun isn't shining or the wind isn't blowing. Quantum batteries, with their potential for simultaneous charging stages and improved thermal efficiency, could provide a solution. They could store large amounts of energy efficiently and release it precisely when needed, making renewable energy a more reliable and viable option. Additionally, the use of quantum batteries could also extend to smaller scale applications. Think about your everyday devices, your smartphone, your laptop, your smartwatch. These devices could benefit tremendously from quantum batteries. Longer battery life, faster charging times, and even the potential for smaller, more compact designs are just a few of the possibilities. And let's not forget about the potential impact on sustainability. Traditional batteries pose significant environmental challenges, from the extraction of raw materials to the disposal of spent batteries. Quantum batteries, on the other hand, could offer a more environmentally friendly alternative. They could potentially be designed to last longer, reducing the need for frequent replacements and the associated waste. In conclusion, the potential impact of quantum batteries is vast. From revolutionizing electric vehicles to making renewable energy more reliable, from powering our everyday devices to promoting sustainability, the possibilities are truly exciting. Quantum batteries could be a game changer, ushering in a new era